Look up at the night sky, and you might see nothing more than a sea of twinkling lights, distant stars burning their ancient light across the heavens. But when you truly pause to think, the vastness of it all becomes overwhelming. Each of those stars is a sun, each potentially cradling its own worlds. Yet, for all we know, we are surrounded by an ocean of unknowns. We live on this small, fragile planet, suspended in the cold emptiness of space. And in all this vastness, one question persists, echoing through the centuries. Is there anyone out there? For millennia, humans have gazed at the stars, pondering whether we are the only ones in the universe. From the ancient philosophers to the early astronomers, the possibility of other worlds and other life has ignited the imagination. But it wasn't until the 20th century, with the advent of radio telescopes and space exploration, that we began a more focused scientific search. Now, we have the technology to peer deeper into the cosmos, and with it, a more profound question arises. Could life exist beyond Earth? The answer to this question begins with the realization that the universe is unimaginably vast. Our galaxy alone contains hundreds of billions of stars, and with modern technology, we've discovered that many of these stars are surrounded by planets. In fact, today, thousands of exoplanets have been discovered orbiting distant stars. Some of these worlds sit in the habitable zone of their stars, an area neither too hot nor too cold for liquid water to exist. And where there's water, there's the potential for life. This is where our search begins. Not just looking for planets, but looking for the right conditions, the right environments where life could possibly take root. Imagine a planet orbiting a star similar to our own Sunday. It sits within the Goldilocks zone, not too close to its star to be scorched and not too far to freeze. This planet is capable of maintaining liquid water on its surface. Scientists believe that water is the essential ingredient for life as we know it. After all, every living organism on Earth depends on it. With so many stars and planets out there, the possibility that some of them might harbor life seems not just likely, but inevitable. But life isn't just about water. It's about the chemistry that occurs when water meets other essential elements: carbon, nitrogen, oxygen, and phosphorus, creating the complex molecules that form the building blocks of life. The search for life isn't limited to finding a place with liquid water, but also to understanding what kind of chemistry can emerge under different conditions. Could life arise on a planet that has never known an atmosphere like Earth's? Could life, as we understand it, exist in ways beyond our imagination? This is the profound question that continues to drive the search for extraterrestrial life. Could the chemistry of life be as diverse as the cosmos itself? Beyond the planets, our own solar system holds tantalizing clues. Beneath the frozen crusts of moons like Europa, orbiting Jupiter, and Enceladus, orbiting Saturn, lie vast subsurface oceans, hidden worlds where life could, in theory, thrive. These moons have long fascinated scientists because of the warmth beneath their icy surfaces, a warmth generated by the gravitational pull of their parent planets. Could these oceans harbor the right conditions for life, isolated from the extreme cold and radiation of space? Could microbial life, perhaps resembling the deep-sea creatures that thrive in Earth's most hostile environments, exist in these distant worlds? Then there is Mars. Once, Mars was a warmer, wetter world, with rivers, lakes, and perhaps even seas. Today, it is dry, cold, and barren, but signs of ancient water flow persist in the form of river valleys, dried-up lake beds, and minerals that form only in the presence of water. It's tantalizing evidence that Mars might once have been a cradle for life. So, we've sent rovers like Perseverance to roam its surface, digging through rocks and analyzing soil samples, searching for clues of microbial life. Mars may hold the answers to whether life existed elsewhere in our solar system. And if we find signs of ancient life, it would be a monumental discovery, suggesting that life is not confined to Earth alone. But it's not just about planets and moons. There's another approach in the search for life that involves listening. The search for extraterrestrial intelligence, or SETI, is an effort to detect signals from advanced civilizations. Using radio telescopes, scientists scan the cosmos, hoping to detect repeating signals or patterns that might indicate the presence of intelligent beings. It's a search for something more than microbial life, an attempt to find beings that are capable of communication across the stars. But for all the technology, for all the listening, the cosmos remains silent. And yet, the search continues, because in the vastness of space, there remains the possibility that we are not alone. The question of whether we are alone in the universe is a question that sits at the very heart of our existence. The universe is staggeringly large, and the odds of Earth being the only cradle of life seem increasingly improbable. There are over 100 billion galaxies in the observable universe, each with billions of stars and potentially even more planets. Statistically, the likelihood that Earth is the only planet to host life is a notion that seems harder to accept with each passing discovery. And yet, as we search, the silence persists. Why is it so quiet? Is the universe truly teeming with life, but we have yet to hear its echoes? Or is the answer something we've yet to understand? To help us understand the probability of life beyond Earth, scientists have turned to the Drake equation, a formula that attempts to estimate the number of active, communicative civilizations in our galaxy. The equation factors in everything from the rate of star formation, the number of planets that could potentially support life, and the lifespan of technologically advanced civilizations. But even the Drake equation highlights the uncertainties we still face. Some variables are well understood, but others remain educated guesses. And this uncertainty is what makes the search so exhilarating and so elusive. Today, humanity stands on the precipice of a new era. With powerful telescopes like the James Webb Space Telescope, we have the ability to peer deeper into space and study the atmospheres of distant exoplanets in more detail than ever before. These telescopes allow us to detect the chemical fingerprints of gases such as oxygen, methane, and water vapor, gases that are often associated with life on Earth. Each discovery is a step closer to answering the question of whether we are alone. And every day, we are learning more about the conditions that make life possible. But the search for life is more than just a scientific endeavor. It is a journey of exploration, a quest that reflects our fundamental need to understand who we are and where we fit into the vast cosmic puzzle. We are driven not only by the desire to find life elsewhere, but by the hope that, in discovering other forms of life, we might better understand ourselves. What would it mean to find that we are not alone? To know that life, whether in the form of microbes or intelligent beings, exists beyond our planet? Would it change the way we view our own existence? Would it redefine our place in the universe? Perhaps the search for life beyond Earth is not just about finding other beings, but about understanding the very nature of life itself. It is a search for connection in the vast, lonely expanse of space. The answers we seek may take lifetimes to uncover, or they may already be out there, just beyond our reach. But in the search, we find meaning, purpose, and a deeper understanding of our place in the universe. And in that search, we are reminded that the cosmos is full of infinite possibilities. The question is not just, is there anyone out there? But what does this vast universe hold for us?